is time for one of my truly favorite topics, cool scatter plots. This time, I'm going to have you go ahead and start with the notebook that I have provided for you with starter code. It's actually common in computer science classes to receive notebooks and documents with starter code. Now, I don't give you much because I like to have you all learn how to create the code on your own. But I don't want things to be too tedious. So when it comes to doing things like typing in, copying and pasting column names, well, let's just say this time I'm happy to give it to you as we get started. So let's go ahead and give this a text title here. This is the abalone shell data, okay? And I think what you want to do is go ahead and run it and take a look at it, okay? Oh, one other thing before you do that, if you tried to run it and it didn't work, don't forget, you may need to go to File, first, save a copy in Drive, okay? You need to do that to make my notebook your notebook. When you do that, I'll go ahead and do it and show you, okay? Go ahead and do that if you haven't done it already. I press copy and it says copy of, okay? But now what's nice is that you all call it your own thing. I mean, you call it the same thing. It becomes your own notebook and you can run code now, which is what of course you want. Okay, so run that first cell of code and hopefully we will get a nice and clean abalone shell data. There you have it. This looks good. Okay, a lot of numeric columns for scatter plots, and I do want to note the final column, rings. These are the numbers of rings in the abalone shells. Apparently it's a tedious process to open them up and determine the number of rings. Assuming like with trees, that would give you the age. But the idea is that, well, wait a minute, can we use the length, diameter, height, and the different weights to actually compute the rings? That's the machine learning problem here. Well, we're going to explore this concept through scatter plots, okay? So let's start with the very bare bones basic scatter plots. Give this a new subheader here. Let's call it default matplotlib scatter plot. Okay, this is just like if, you need something really fast. What do? Well, you're going to need to go ahead and code with me. Import matplotlib.pyplot is PLT. There it is as an option. Then you do plt.scatter. Now, scatter plot compares two different columns, okay? If we look at it in terms of rings, maybe the diameter makes sense. The bigger the diameter, the bigger the rings. So I could have my x, which always comes first. Call it df. Put the quote in there. There it is, diameter. I pause because, if I'm just looking at it, I don't know if it's uppercase or lowercase. And then the rings. Okay. And then finally, you want to do plt.show to get rid of some unnecessary code. Okay, there you have it. There is an upward increase. I mean, it's only so revealing, right? I would not call this a cool scatter plot yet, but I would call this, right, this is a default scatter plot. And just to show you one more important piece in a default scatter plot, I'm going to go ahead and copy this in here again. And it's alpha. So recall that alpha means transparency. And if I do like 0.4, which is a nice one, well, that's a little more revealing because now I can see where it's lighter, it's likely only one value, like way up here at the top. But it's really dark in the middle. That means you have overlapping values, okay? In case you're wondering, like, well, how big is my data set? How many rows are there? Well, one way you can quickly do that is length of df. You can say there's 4,177 rows. So that is quite a lot. And sometimes you will find that you can actually get more revealing graphs by looking at smaller subsets, okay? And we will consider that option. So that's the default, not yet a cool one. And so how are we going to make one that's cool? We're going to use Seaborn, okay? So let's just get right into it. do a new subheader, and let's go with Seaborn scatter plots. If the Seaborn scatter plots, it's going to look a little bit different. Okay, so it's sns.scatter. I think it's sns.scatter. Sometimes, you know, it's a scatter plot. It is scatter plot. It's a little different. So it's scatter plot. And, you know, we can do the same X and Y deal. So I think we can mix it up too to get more information. Like maybe instead of diameter, let's try length. Okay. You would expect to see something similar. So df length. Typically in the Seaborn, you want to actually write X equals for that. Okay. And then we'll do Y equals df rings. And let's just start with this basic and then see what we get. With one exception, I do want to change the figure size. So let's go with, oh, and I want to change, oh my gosh, I'm getting ahead of myself. Let me show you what happens if I do this. Look at that. SNS is not defined, okay? Sometimes we forget these things, right? We're so used to using them. So it's import Seaborn as SNS. We're going to make this a full piece of code. So we're going to go ahead also and import matplotlib here. Again, why do I do this? So that this chunk of code you can copy and use later and it'll work as is. SNS.set. So those are like the preliminaries, okay? Now that should give us the basics. Okay, we're going to keep adding to this, but it's good to check it, make sure the code works. There you have it. I can't say that looks better, but there you have it. Right? So what do we do to actually improve this? Well, one thing we can clearly do is change the figure size. So plt.figure, and then it's parentheses, fig size equals, I don't know. So I honestly tried different ones. As I might just look at my computer and estimate. Maybe, so it's always like horizontal, vertical, row, column, 10, 5. That's a starter there. Okay. Looking a little better to start with. Now, before we get into the size, I want to share with you what actually makes these really cool. Okay. And you may have seen these scatter plots before. You can, in fact, change the color and the size based on additional information. Okay? What I mean is this. We could try size and not set it to a numerical value, but rather we could set it to a one of the other columns, like df sex, okay? And then what it's going to do is it's going to show different sizes depending on the sex. And what's really cool, I'll put these in a, you can press return on it when you're inside of parentheses here. You can do something similar with color. Now here it's hue because it's not like the color of the graph, but again, it's not a color, it's a column. So I can pick another column here to help. It just gives more information and it's going to make it really cool. So I'll try like, I don't know, let's try the shucked weight. Why not? Okay. So that's going to be the starter code here. And looking at the image I have, I'm going to make mine a little bigger. I'm going to go 11 by 7 maybe. It might be too big. We'll see. Okay, so try that. And you're free to pick different columns. The point here is to add a size and to add a hue. Okay. In addition, you should be tweaking the fig size based on what's on your computer, not on mine. Okay, run that. Looking better. Looking better. Okay. It's a little blurry on mine. But remember, like, they look really nice when you export them. So you can see that the sex, it's hard to tell the difference between male and female. I may be indeterminate. And the weight, it is absolutely clear that as you get the length gets bigger and the rings get bigger, the higher the weight, the further it is down there, right? I mean, that just makes sense. If it's longer, they're going to weigh more. That's absolutely clear from this diagram. Okay, so we're interpreting these. I think 11 is simply too high, so I'm going to change it. What else can we do? Let's get an alpha in there. Okay, I'm going to put the alpha up here. Alpha equals 0.8. Give it a little transparency. Got to put the comma in there, okay, because we've got another line there. And what else can we do here? So one thing you can do, like I could say, well, I'd like more size differentiation. And so I can, with the sizes, you can actually set the minimum and maximum through sizes here. So I'm going to try something like 5 and 500 and see what that does. Okay. I don't really know the sizes well, like what's it showing versus what is this. But let's try this now with these changes. Whoa. Too big. Too big. I need to tone that down a little bit. Look how big it is. Let's try. Look, the eye's so tiny you can't even see it. Okay, come on, Mr. Wade. Let's do better than that. Let's try 15. And how about 150? That looks a little better, right? So I still think it's a lot of overlap. You know, it's a little too much for me, honestly. And somehow I think this would look cool too if I stretch it out more. You know, like 13. So when I say there's too much overlap, recall how many rows there are. So what if we take a subset? Okay. Let's just try this. So if we're going to take a subset, right? So df, and maybe I'll call something differently in case I don't like it. So df sub, all right, sometimes I use how many rows? df 100, okay, equals df. Can you write the code to get the first 100 rows? There are different ways you can do that. df.lock, starting at 0, ending at 100. And now, if I'm going to be switching it there, I actually need to switch it here too. Okay. So this is just going to make it a little less crowded down there. Okay, and I'll make that note up here. It's a kind of a cool technique. So take subset of data to make less crowded. Right? Put in a little more notes here. Import matplotlib and Seaborn. Change figure size. And now these are my cool scatter plots. Why cool? Because again, when you're having variation based on information, like, oh, different colors mean different things, different, what is it, sizes mean different things, I think it's really cool. Let's try that. Okay, see, this is why I changed it, because I think, well, that's too sparse. Okay, let's mix it up a little. How about, I don't know, like maybe 1,000. Now, what's cool about this, right, because, see, I mean, I called it df 100. You know, I probably should have called it something differently, because then you can just keep changing it. So maybe df sub. How about that? Then I don't have to write it. So I'm trying to get more information, but not overload. And this is a part of it, like for me personally. I tend to keep going until I get like a really nice graph. See, I think that's better. Okay, I really think it's better. And then, by the way, we haven't really analyzed the male-female thing. But if we look, that one up there does look like a female. Are the males a little bigger on average? Maybe slightly. I don't know. We'd have to, you know, I don't think that this reveals that clearly. The other thing is that you can try some different pieces here. I think that 15 may be too small too. And I think I like to go a little bigger maybe. And maybe we don't need the transparency if we're, you know, being a little sparse. I may even go down though. This is how I tweak things. I think that looks a little better, yeah, without the alpha. And again, I may do a little less. These are the type of things I do, right? Because I'm trying to make as clear of a presentation the data as possible, okay? I think that's getting better. All right. What else can we do with this? A lot. I want to though, like, I want to get some new variation, like not just the sex. Like, let's try something else. And before we had the diameter, let's throw it back in here and see what that does. Now, when I got that error, right? This is the advantage of running code with small changes. You know what the error was, right? Because I only made one change and it worked. Now it doesn't, and it says key error diameter. That's actually a very common error. It's when you misspell the column name. Diameter, diameter. You can always go back up and copy it. Okay, that looks cool, right? Look at these variations in diameter. Right? It's more gradual, and you see that variation getting gradually bigger as it goes up. And that's right. I still want it bigger. Try to double it. Here we go. Oh, I like that. I like that. I think that looks clean and nice. Okay. See, I mean, yes, I'm giving some aesthetics, right? But graphs should be aesthetically pleasing. Okay, I think that's an aesthetically pleasing graph. Okay, let's close this one out with the following. Recall the saving. Okay, save graph, and we do that. That's plt dot. If I start typing save, see, I get it. Save fig. I haven't even given it a title yet. What should the title be? Let's give it a variable. Title equals, so what do we got here? Rings, these are abalone rings. Maybe let's call it abalone rings. You know, I think the rest of it will have X, Y labels. By the way, notice this, when you're doing the Seaborn scatter plots, this is really nice. The X and Y are labeled by default, so you don't need to put that in there. But we do need the title, okay? So give title. I'm just giving it a variable so we can use it twice. So plt.title. Yes, you can do this. Put in title because it's a function and a variable here. And Python knows how to distinguish. And then I can also do it here importantly with title. And let's set the DPI again. I think 200 is nice. Seems to be sufficient for a really crisp graph. So let's try that. It should be about the same. It's just really giving a title and saving it. Press Shift Enter. See, I got the abalone rings up there. And again, we've got the X and Y, the length, rings, the shucked weight, and the diameter. This is nice. So now let's find the saved figure and look at it. They're just so much more beautiful when you see them crisp. All right, here I go. Click on abalone rings. Well, clicking does remember something different. Download it. There it is, down there. You should have the same deal. I click on it. I do have a laptop open, and it goes over there. So here it is. That's gorgeous. I mean, look at that. Cover up the one down there. It's just gorgeous. That is a gorgeous graph, right? And that's what we do here. I am training you all not just how to like do some code, but how to do code professionally. Okay, that is a professional graph. It's just beautiful. I mean, it really is. And this is where having the precision of things like 4K video, which this is recorded in, or just simply like looking at it on your own machine. It can be hard sometimes when it's, you know, published online and then maybe like you don't have as good of a connection as someone who created it. But when you do that DPI, it's going to look good on a machine, and it looks great on mine, I can tell you. Hopefully it looks good on yours. Oh, I love the gradation of color. This is exciting. We're going to do more.